let me also take this question from Joe. I think private networks is the ecosystem is the base to generate data, and data which goes in the cloud, AWS or whatever, to make data analytics, bring it back to the edge, and get more efficient in the process, and that is for me very, very important. And that for me it's important that the companies are working together to be more efficient or productive in the field where you're working with 5G. And AWS also announced that they're also going on 5G. So 5G, let me say, is the base communication for the digital transformation.
Let me address this as well from my perspective. So the issue of data is now fundamental. So we need to look at data sovereignty. Data sovereignty is not yet possible in Europe, as long as we have the US Cloud Act, which basically forces all companies, especially US ones, working anywhere in the world, to save their data in the US. So they're entitled through the Cloud Act to have access to this data. So the European Commission has been promoting the Gaia-X data sovereignty platform, which is just picking up so that all the data should be stored and saved in Europe and not taken anywhere else from Europe, so that will protect basically the data in the cloud. So I know that AWS is committed to do that, but I still have my doubts that they are not going to comply to the Cloud Act. So this is a very touchy topic. We have to be very careful about what we promote here. Okay.
Thank you, guys.
Something, and also about data sovereignty is also the question where you really want to store the data at the end of the day. So do you really have data you can move into the cloud like AWS, or you want to start with a data-centric architecture where you collect all the data? And this is also regarding the question of Henning. Bringing data into the cloud is one thing, and then operate on and analyze the data. The question is, does it make sense depending on the location and where I want to drive my analytics afterwards with this data? So 5G on the one side is only, let's call it the transportation layer of this kind of data, of sensors in the manufacturing infrastructure, where you have OT connectivity, for example, directly on the production line. And the question is where you put this data into. So what we see in most cases, that customers saying this kind of data will be stored locally in a local infrastructure in a hybrid cloud environment, and not all the data will be forwarded into the cloud.
Uwe, I totally agree, and I know it from the automotive business that they have they call it industrial automation center, where they store the data, make the data analytics, and only data which you need for a long period goes into a cloud. And in the most case, it is a cloud on premise. So you have the cloud functionality on site and can work with the data. Okay. And I think in the moment, and that was also when I was saying what is the benefit of a private network, the data stay on site, and you as a customer, you make the decision what you do with the data. Bring it into the cloud in let me say in Frankfurt or whatever, or does it stay on site, let me say in Wolfsburg at Volkswagen?
And you also then can adopt the zero trust methodology and solution to this kind of requirements as well, in addition. Yeah.
Great, thank you, guys. Let's go. We will have a lot of questions from our. We will leave many of them our questions, and I think we have a new question for Latif. And Latif, what is the impact of IPv6 on manufacturing?
Yeah, that's a very good question. So basically, I've been in touch with the Industry 4.0 in Germany, and the same thing in the UK, based in Manchester. So I was a bit taken back by the Industry 4.0, at least a couple of guys that I met, and they don't think highly of IPv6 for whatever reason. So they think, we're going to just use 5G, but they don't know that data has to be packetized somewhere and put in packets sent out there. So they have not been promoting the new internet protocol, still proposing the old one, which is disrupting basically the communication. So you will not get any proper security end to end. So I would like maybe to appeal here to the community of the Industry 4.0 to rethink their model, not using the current internet protocol because it's not made for the industry anyway. It's only a still research protocol. So the production protocol is IPv6. I think they will benefit more from basically doing interconnectivity between all manufacturers. So you have, if you take the car industry, there's a full supply chain. So you want to track every little device with its numbering, whatever you have to key in, onwards to the dealer and to the customer. So it's very important to have that non-interrupted chain in the communication, but also adding to it security and privacy and so on, which is not yet the current case. Okay?
Thank you so much, Latif. Uwe, do you see Wi-Fi and 5G complementary or contrary?
Yeah, so Wi-Fi and cellular like 5G are often portrayed as competitive technologies. But there's something to this, yes, but it's all to the customer's benefit, and the two technologies can complement and work together. So 5G wasn't designed preliminary for cell phones. So the real value of 5G is at the end, and we discussed this many times here, is the Internet of Things, so IoT applications, in which connected devices with limited smarts perform tasks that require communication back to the network, such as on large campus, so that's what we discussed, and farms somewhere, for example, on the highway, or spread out through a factory or city. So that's something where 5G is definitely the better connection or connectivity. These are applications where Wi-Fi may not make really sense, but there are also network applications for which 5G is better suited than Wi-Fi, even if both are available. So most enterprises rely on Wi-Fi technology. That's what we see today in manufacturing, in automotive space, in all infrastructures, our customers. That is still going to be the most popular option. And of course, with good economic scales. But the WBA has made several interesting studies and on the capabilities of both Wi-Fi and 5G. The results shows that Wi-Fi has more devices and better cost per end devices than 5G. So there are areas that better availability. 5G is designed to make Wi-Fi an integrated part of the carrier network. So Wi-Fi 6 and 5G have been designed to work together in many ways to optimize performance and user experience at the edge. So what I think is 5G is increasingly useful to the enterprise, and especially for manufacturing, but Wi-Fi will likely be an important part of any 5G deployment. So there's no 5G services that can not be delivered to a device over Wi-Fi. So 5G is expected to become more dominant in the industry. That's what we see. So based on the use cases that involve high mobility, large area coverage, and indoors and of course outdoors connectivity. So that is aligned with what we already see with customers. Wi-Fi is complemented by 5G for the outdoors, for mobile usages, and when energetic efficiencies are needed.
Uwe, let me also add one point when you say 5G and Wi-Fi 6 or whatever. I think very important is for machine builders when they have, let me say, different customers. One customer prefers Wi-Fi and one customer prefers in the future more 5G, that the software which is running the application is based on an open standards like OPC UA OPC UA has also the benefit, it's a secure protocol, and that makes the world for the machine builders a little bit easier. And I know it from my old company. Also, devices, what we created, the end device for 5G and also for industrial wireless LAN, has the same footprint, and that makes it for the machine builder very easy to fulfill offer for wireless LAN or for industrial wireless LAN and for 5G, because the software has the same API, and to change one module to the other, it's not the big deal.
So maybe one point, now there is a story which happened to Volkswagen when Wi-Fi collapsed for one day and did not produce 5,000 cars. So this is hanging in the air in the car industry. So there would be a bit of a suspicion to use the Wi-Fi in a very large scale. You can use Wi-Fi 6 in smaller scale things, but not in large scale stuff.
Okay, Latif, I know the story from Volkswagen very well, because I work very close with Volkswagen, and I can tell you, yes, the wireless LAN broke down and they did not produce cars, but in the end of line they have industrial wireless LAN, and they still could produce or bring out the cars which are already in the line. And that was also the question from the IT department, why the guys with industrial wireless LAN can produce and the guys who choose wireless LAN could not produce. And I think that is a big difference when you talk manufacturing. Manufacturing and car manufacturing is very popular. 24/7 is a must, and therefore the customer willingness to pay is there, to pay a little bit more. And that was also the success from industrial wireless LAN, what we have with my old company in the field. And that is something where we have also to come with 5G. With 5G, in the moment we had release 15. We have not the low latency in the moment, therefore we release 16. And then we come also in this area when we are talking more about industrial 5G, and then we will have a really reliable network.
Sounds good. Okay.
Thank you guys for the answers and for the use cases that you are mentioning. I am sure the audience love it, and well, this is what it's about. Let's see where I am. Ewald, digital transformation in industry. Which key technologies will play an important role?
I think when I look at the key technologies in the future, I think the first one is an open protocol, which will be support from many companies, because it makes the life much easier also for machine builders, for small enterprises, SMEs, and that is OPC UA, what I already mentioned, and also with the benefit the security integrated in the protocol. The next technology, because not everything will be wireless, is the time-sensitive networks, also based on the Ethernet standards for wired communication, but also, let me say, with the same feature set what 5G is offering, real-time capability. And I think these three things, for wireless, for wired, and with the open protocol, will be the future. And we see it that there's also an alliance which is working on these OPC standardization for safety requirements, because one important thing with 5G, what we will have, is safety. And it is more important to be very open than security. Safety to save the life of the people in a factory is so important, and so safety is a must. What we will must have if we go, let me say, in a broader scale with robots, AMRs, or AGVs, and that is also where many companies are working on it. And so to summarize, it's 5G with safety functionality, TSN with safety functionality, and OPC with safety functionality as well. And I can tell you the OPC safety spec is ready, and the first tests were very successful, also over 5G and also over wireless LAN, because I always say make it very easy. Wi-Fi and 5G, that is only the motor in the AGV. And if I can change it very, very easy, when I have the same application software runs on OPC UA, it makes the life very, very easy. And that is important for machine builders.
And let me add, Ivan, something exactly, and this is not valid for manufacturing only. This can be adopted in different industries where it is really, really key.
Yeah.
And where this is really, really key is in the healthcare environment, where they are dealing with similar use cases where the location, availability, and connectivity is really key. Yeah.
Thank you, guys. One more question for Latif. Latif, what is the impact of IPv6 on blockchain?
I think I touched a bit on it, and this would be also very important for the car manufacturing. So the enterprise today, and to be honest with you, our security experts on the internet did not do a very good job. That's why we're still suffering. Especially, network address translation has been added to the internet, making it a telecom internet. It's no more the original internet, which is end-to-end. It'll be able to do IPsec and VPNs and so on. Today, these security things are broken by NAT. So the only way now to do it is to use blockchain, which in this case gives you multiple functions. So it will be the end-to-end model, which is very important. So if we look at the backbone, because they have routable IPv4 addresses, that's why they're using IPsec and so on. But when it comes to end users or new industries getting into the internet, they do not have routable IP addresses. So they need them, they can get them only from IPv6. So in order to restore the end-to-end security model, they have to move to the new protocol. And I'm very pleased to tell you that in the meantime, we have 2.5 billion people using IPv6 without knowing it, which is the purpose of this exercise. Otherwise, it will not be very well deployed. So it just works by itself. We just need the ISPs to do that. And by having that, matter of fact, Germany is number one in Europe with about 40 million V6 users, but not too many people know about this. We have the IPv6 Council in Berlin at the Hasso-Plattner Institute, which has a certain number of key players, especially with Deutsche Telekom, as we have promoted the idea to them. That's why we had IPv6 deployed in Germany basically in a couple of years. And currently, it's rather Asia which is moving very fast to deploying the new internet protocol because they didn't have enough IPv4 addresses. Like India had at that time only about 200,000 IP addresses for 1 billion people. And China had only 8 million IP addresses for 1.4 billion people. So they saw that they are really behind on the internet. So the leapfrog effect is happening in Asia. So I would expect that 2/3 of the IPv6 world is going to happen in Asia. So they will be more advanced than the rest of us, as we in Europe, we have only about 140 million IPv6 users for the 500 million users. And the US, although the US government has promoted IPv6 in their own networks, which is one of the largest networks in the world. So they plan to have IPv6 only and take out IPv4 because of all of its inefficiencies and insecurity and so on and so forth by 2025. So we've been promoting this to the European Commission, but they don't understand what IPv6 is. So they're rather going into NGI, which is a concept with no standards. Nobody's promoting any new standards in such a way. As a matter of fact, they're not even promoting IPv6. That's why Europe is a bit behind in the deployment, except Germany, Belgium, as of late, France and the UK are moving it, but the other countries are a bit behind. So there is a bit of a learning curve here for Europe. Okay.
Thank you so much, Latif. I have to say we have a parallel debate in the chat, in the public chat, which makes me feel that next Tuesday during our networking meeting we will also have a very nice session, being able to discuss many things, and of course some of the questions that today we don't have time to answer. We are still having some more time for a few more questions. For example, for Uwe, what are the must-haves of private 5G?
Okay, looking to the timing, I will be very fast to answer this question. So what we see, what are the must-have for a 5G is it needs to be fast and flexible in terms of deployment. So I would like to have a deployment under 1 hour at the edge. The second point is easy to operate. So easy to operate for the company, for the enterprise, similar to how we operate a Wi-Fi network. So it needs to be integrated. And also for service provider, if you have a service provider running your infrastructure. And the third one, I think this is more or less the key one, is it needs to work well with Wi-Fi. So look like 5G with Wi-Fi as a single network, and at the end, adding the option to consume this 5G, private 5G as a service as we know it from our private GSM connectivity. So these are the key three must-haves we see for private 5G.
And also, let me add one thing. Also, on the development phase from the companies, it's very important that the development is KISS. That means the end product must be keep it simple and secure. And simple means that also the blue collar worker can handle it, because when I compare it with Wi-Fi, all the Wi-Fi applications which are outside, also let me say a kind of private network, they are handled from the blue collar workers on the plant or whatever. And that's the same requirement what is there for 5G. And so it must be easy to change, let me say, a device less than 60 seconds. And when you compare it, let me say, with your smartphone, when you will change it from one to the next one, it takes much longer. And that is something where, let me say, companies which come out of the industrial automation arena have a clear focus on that. And I can tell you with some of the devices which I created in my phase, you can do it in 60 seconds.
Yeah, but Eva, as you said, but this is depending on the device, on the use case, and what I said, the real integration that 5G and Wi-Fi looks like a single network.
Yeah.
So that you don't have anything to change on your device, so that needs to have seamless handover from technology, from the network technology, from the device perspective.
Yeah.
Great, thank you. One more, or the last question that I am going to ask today is for Ewald. Ewald, connecting brownfield, which feature is a must-have?
Yeah, I think brownfield is very important, because the most applications which will now move to 5G are not greenfields, that are brownfields. What we have also in automotive, it's much brownfield, but also in process automation, and they use field buses. And the world-leading field bus is Profinet, a layer 2 protocol based on Ethernet. And the requirement was very early there to have a migration from Profinet over 5G. And they make it also very clear over a private 5G campus network. And that is a must-have. And at the last Hanover Fair, some companies already showed that is possible to have this kind of migration, because we have a great installed field worldwide. Nearly 15 million nodes are repeated, and that is an important thing for many of our 5G, let me say, future customers, that we can have these migration part. And that is for me a must-have. Not for me, it's for the customer a must-have, and especially here in automotive, because automotive in Germany, they make a clear decision. 10 years ago, we go for Profinet for Profinet with safety included. And that is also the requirement what we must fulfill later on with industrial 5G to be successful. And when I'm talking about Profinet, also the German automotive companies make a clear requirement. We need a certification for Profinet that we can mix devices and controllers. And the same requirement is also there for 5G, that I can take different devices to connect it to different cores, Open RAN or not, and it must work very easy.
Thank you, Ewald. Now, I would like to ask three of you any final point or messages you would like to send, to address, to say to the audience about whatever we have been speaking today. Let's say maximum 30 seconds each one of you, starting with Latif.
Yeah, so I guess to realize what has been discussed now, we need to move to IPv6 100% by 2025 in order to realize all of these things. So there will be 6G, which has far more limitations than 5G. So 5G would be with us for a long time. 6G is going to terahertz, which has certain limitations. So it can be used only indoor, but you could replace basically the spaghetti of optical stuff by using terahertz modems. So in the production assembly lines, which you have to change maybe every 2 weeks or something like that, it would be a lot easier to do with terahertz indoor. But outdoor 6G based only on terahertz is not a good thing. So we'll have to combine, in this case, 5G and 6G in the future. Okay?
Thank you, Latif. Uwe, your final statement, final message?
Yes, so if you look for a 5G private or private 5G, look that it's enabled for autonomous operation, that the solution supports critical application, it's dedicated use network, example, virtual private 5G, and think about a test environment available before deploying it to test your use cases.
Thank you, Uwe. Ewald, your final statement, your final message.
I can only agree what Uwe is saying, and to make it very short, start now and make your own experience. Don't wait for the next release on 5G. Don't wait for 6G. Start now. Make your own experience, because that is the best thing what you can do. And there are many, let me say, test beds outside where you also have the people with a 5G DNA to help you with your applications. And also what Uwe is saying, there are many, let me say, mobile ecosystems which you can rent or you can buy, also with services on top, and start now and make your own experience, and you will see the benefits from the 5G technology.
Thank you, Uwe. And now, well, this was the last question from about this the webinar, this very interesting digital event. Thank you, all of you, for joining us today. We hope that all of you enjoyed it. I did it. Special thanks, of course, to our three great panelists, Ewald, Uwe, Latif. Really amazing sharing the panel with you today. Now, I am going to provide you a little present in the name of the EUTEC. As you may know, one of our main goals at the Chamber is the sustainability activities, and we always provide to all our speakers a tree certificate. That means we are planting a tree in Africa in your name in order to help with the CO2 emissions reductions and with the environment, with sustainability. So let me see where I am here. I am sharing my screen. You can see it clearly, but well, one tree certificate for Uwe Welzer, another one for Latif Ladid, and another one for Ewald Cook. Thank you very much, guys, for your participation here today. I am very happy to count on you. I am very happy also if I can count on you next Tuesday in our networking meeting. Thank you again to all the audience. See you very soon. And as always, remember, technology obliges. Thank you so much, and goodbye.
Thank you very much.
Thank you. Thank you. Bye-bye.
Bye-bye.
Bye.